Hello and welcome. Today we are gonna integrate this function, integral 1 over square root x to the power of 2 minus 1. So how we're gonna integrate this? Well, first we are gonna do what's called trigonometric substitution. That is, we let x equal secant u. Well, if x equals secant u, then x to the power of 2 equal secant u to the power of 2. Then I'm gonna make a line. So now we have two sides, left and right. On the right side we're gonna work on our integration, and on the left side we are gonna put all the resources that we need for the integration. So now we have integral 1 over square root secant u to the power of 2 minus 1. We just change the x to the power of 2 to secant u to the power of 2. And then what about dx? Well, if I wrote dx right here, now we know that we integrate this function in terms of u with respect to x. So this will be wrong. Instead, we're gonna try to find du. Well, how do you find du? Well, we're gonna derive this equation with respect to u. So what happened is we derive the left side of the equation, that is x, with respect to u, and because if this is x, we're just gonna leave it like that. So it's dx over du, and the derivative of secant u with respect to u is secant u tangent u, and then we multiply both sides by du. Therefore we have the value of dx secant u tangent u du. So instead of writing dx right here, we're gonna write secant u tangent u du. Now all the variables now in terms of u, we're gonna change this value. We know that secant u to the power of 2 minus 1 equal tangent u to the power of 2. If we square root both sides of the equation, we're gonna have square root secant u to the power of 2 minus 1 equal square root tangent u to the power of 2. Square root tangent u to the power of 2 is just tan u. Therefore, we have integral secant u tangent u over tan u du. Now we're just gonna remove the tangent. Now we're left with secant u. Now we know the integration of secant u is ln absolute value of secant u plus tan u plus c. But we're not finished yet. Now we need to change the variable of our answer from variable u back to x, because we start with integral in terms of x. We have to have a result in terms of x. So what we're gonna do is that, if you notice that secant u is actually x, and therefore we can just change this to ln x plus. But how about tangent u? Well, we're gonna draw a right triangle. One of the angles 90 degree, and our angle u, for example, in this place. Then this is gonna be the opposite. This is gonna be the hypotenuse, and this is gonna be the adjacent. Secant u equals hypotenuse over adjacent. Well, we also know that secant u is equal to x. I can write x as x over 1. So hypotenuse is x and adjacent is 1. But how about the opposite side? Well, if we use Pythagoras theorem, we're gonna find out that this is square root x to the power of 2 minus 1. So now we can find the value of tan u. Well, tan u equals to opposite over adjacent, which is square root x to the power of 2 minus 1 over 1. So now we know secant u and also tan u. We can put our answer. The final answer are gonna be, I'm gonna write tan u first, x to the power of 2 minus 1. So our final results is ln absolute value of x plus square root x to the power of 2 minus 1 plus c. This is our final answer. I hope you guys find it helpful, and I'll see you next time.